Today we're looking at graphing a linear inequality, and we will use our understanding of graphing linear equations to do this. First, a few notes. We have two types of symbols that represent a dashed line when we graph an inequality. Less than or greater than is a dashed line. Less than equal or greater than equal is a solid line. Why do we use a dashed line when we're graphing an inequality? Well, when you graph an equation, you're graphing points that are solutions to the equation. For example, x plus y equals 6. If we know that x plus y equals 6, then 2, 4 is a solution to that equation because 2, 4, 2 plus 4 equals 6, making that a true statement. What would be another solution to that equation? 0, 6, 1, 5. We could come up with all sorts of solutions such that the x and the y add to equal 6. When we graph these points, those points are on the line. The line is the line that makes all of the points equal to 6. So when you're using a symbol that is less than or greater than, you're showing that the line is the boundary line, but those points on the line are not solutions. So we dash the line because the points are not solutions. The solid line is when the points on the line are solutions because we're using a symbol such as less than or equal to or greater than or equal to. Remember, a solution is an XY ordered pair that works when you plug it into the inequality or the equation. It makes a true statement. The other way that we're going to show solutions in an inequality is we are going to shade, because you have a boundary line that divides a coordinate plane into points on the line, make the equation equal. Points on one side would make x plus y greater than 6. Points on the other side would make x plus y less than 6. So we end up with 3 regions in the coordinate plane. A line which is equal, one side which is greater, one side of the line is less than. So to shade the correct side, you will pick any point not on the line, pick a test point, and plug it in to see if it makes a true statement or not. Then we would know which side to shade. So option 1 is graphing a line using the x and y intercepts. So let's take example 1. Find the x-intercept. How do you find the x-intercept? All the points on the x-axis have a y value of 0. Therefore, you're going to substitute 0 into the problem and you're going to solve for x. First, we're finding the points on the line, which we want to find the points that make 4x plus 2y equals to 16. However, what kind of line will we use? Since it's less than only, we will use a dashed line. But I'm first going to have to draw the line that makes 4x plus 2y equal to 16. So the x-intercept, 4x plus 0 equals 16. So x would equal, divide both sides by 4, and 16 divided by 4 is 4. So x equals 4 when y is 0. So the point 4, 0 is a point on the line. Find the y-intercept. All the points on the y-axis You either moved up or down. You did not move left or right. Since you did not move left or right, you have an x value of 0. Substitute 0 for x. 4 times 0 is 0, so you're left with what value of y makes 2 times y equal to 16. Divide both sides by 2 and you get a y value of 8. So 0, 8 is the y-intercept. We can now use rise over run to see that the slope is down 8, right 4. Negative 8 over 4 is negative 2. So we can fill in negative 2 over 1, down 2 over 1, and we find more points that would be on the line. Since it's less than only, then these points only make up the line that would make 4x plus y equal to 16. Are the points on this line solutions? No. Hence the reason why we dash the line. Now, the line divided the coordinate plane into 2 regions. One region makes all of the xy ordered pairs less than 16 when you substitute it into the inequality and you do 4 times x plus 2 times y. The other side of the line would make all of the points greater than 16 when you plug it in. So we need to decide which side makes the xy ordered pairs when we plug them in makes it less than 16. So let's pick a point. Since 0, 0 is not a point on our boundary line, we can substitute 0, 0 into 4x plus 2y and see if that gives me a value that's less than 16. 4 times 0 is 0 plus 2 times 0. 0 is less than 16. Since 0, 0 is a solution, then all of the points that are on the same side as 0, 0 are solutions, and we would shade that point of the boundary line. Any point in the shaded region is a solution. Since the line is dashed, the points on the line are not solutions. Let's look at another example. Find the x-intercept, plug in 0 for y, and graph that point. When you plug in 0 for y, you get negative 3x equals 15. Divide by negative 3 and x equals negative 5. Find the y-intercept, plug in 0 for x, and graph that point. When you plug in 0 for x, you get negative 5y equals 15. Divide by negative 5 and y equals negative 3. Plot that point. We can see that the slope is negative 3, right 5, down 3, right 5. Do that a couple more times. Go the other direction by going up 3 and left 5. Now, look at your symbol. Is this going to be a dashed or solid line? Because we're saying that negative 3x minus 5y is greater than or equal to 15, we're going to use a solid line. What does it mean when we use a solid line? It means that all of the points on the line are solutions. Now we decide which side to shade by doing a test point. I like to use 0, 0 because it's easy to substitute as long as it's not a point on the line. We already know the points on the line make negative 3x minus 5y equal 15. So if we use 0, 0, we get 0 greater than or equal to 15. Is 0 greater than 15? I plugged in 0, 0, and 0 is not greater than or equal to 15. So 0, 0 is not a solution. If 0, 0 is not a solution, then that means any point on this side of the line, any point on the same side with 0, 0 is not a solution. You can check the other side by plugging in a point if you want. I can plug in negative 10, 0. Let's plug in negative 10 for x, so negative 3 times negative 10. We're plugging in 0 for y. So 30 minus 0 is greater than 15. Is 30 greater than 15? Yes. So that just proves that this point on this side of the line is a solution. Since this point is a solution, that means all of the points on this side of the line are solutions. So we would shade in the direction of negative 10, 0 to represent that this side of the line represents all of the points that are solutions to the inequality. So what are solutions to this inequality? Any point in the shaded region or any point on the line. Since we said that negative 3x minus 5y can also equal 15, greater than or equal. So greater than below the line, equal on the line. Another option, obviously, to graph a line is to put it into slope-intercept form, y equals mx plus b, so solve for y. Notice here, there's only one step to solving for y, so it would be easier to put it in slope-intercept form and just use y equals mx plus b to graph it. The one step I need would be to divide by 5. So I'm left with y equals, divide both terms by 5, negative 2/5 x plus 4. I divided by a positive, so I did not need to reverse the inequality symbol, so the inequality symbol is still greater than. So the slope is negative 2/5 and the y-intercept is 0, 4. Start at 0, 4, down to over 5, down to right 5. Negative is always down and to the right. You can go to the other direction by going up and to the left, up and to the left. All right, before you draw the line, you should look at the symbol and see that it's greater than only. If it's greater than only, then the points that we just plotted make y equal negative 2/5 x plus 4, and they are not solutions. So we show that they are not solutions by doing a dashed or dotted line. Now we have to decide which side to shade. So I'm going to use 0, 0 as a test point. I can substitute it into either the original form or the slope-intercept form. If I just go back and do the original form or the slope-intercept form, 5 times 0 is 0. Is that greater than negative 2 times 0, 0 plus 20? Is 0 greater than 20? No. So we substituted 0, 0, and it was not a solution. So we would not shade towards 0, 0. We would shade away from 0, 0. So the only solutions to this inequality are solutions above the line. The points on the line are not solutions. One more example. Put it in slope-intercept form. There's only one step to put it into slope-intercept form, and that is add 7. So y is greater than or equal to 2x, negative 13 plus 7 is negative 6. So the slope is 2, and the y-intercept is 0, negative 6. Start at the y-intercept. Since the slope is positive 2, go up 2 each time. Up 2 over 1. Up 2 each time. You are earning $2 per day if this were a scenario. Is the line going to be solid or dotted? Go back and look at your symbol, greater than or equal to. It can be equal, so the points on the line are solutions. So we use a solid line. Decide which side to shade. Is 0, 0 on the line? No, so substitute 0, 0. 0,